Good morning, everyone. I'm Shilpa, Assistant Professor from AIML Department. So today in this session, we are going to discuss about predictive parsing, and in that, construction of parse table and parsing a string, example string. Here, in to get into the topic first, we'll discuss few points about previous session. What is parsing? Where it is going to be done? And what to parse an input string using predictive parsing, how the grammar should be transformed. Here, parsing, what is meant by parsing? Parsing is a transforming of data from one form to another form, and that means input tokens of data is transformed to parse tree. This can be done with the help of one context-free grammar, and this can be done by a parsers. Parser is a algorithm which is used in compilation process. So in compilation process, in phase of compilation, first lexical analysis generate stream of tokens, and these tokens are going to be given to the parsing algorithm, and there that stream of tokens will be verified whether these are syntactically correct or not. By that, parse tree can be generated. Now, what are different types of parsing technique that we discussed in previous session? Top-down parsing and bottom-up parsing. What is meant by top-down parsing? Parse tree can be constructed from root to leaf. From root to leaf. Parsing can be done and parse tree can be constructed. In bottom-up parsing, from leaf to root, the parse tree can be constructed. That means all the input strings are reduced to its non-terminal, and eventually the start symbol will be derived. If it is done, then we can say that parsing is successfully done. Now we'll be discuss in top-down parsing. There are some different kinds of top-down parsing with backtracking and without backtracking. Now we are in this session, we are going to discuss about the predictive parser. That means without backtracking, we are going to discuss this parser, or this parser can be known as LL1 parser. This is a model of the predictive parser. Here in this predictive parsing algorithm is going to communicate with input buffer, stack, and parse table. See, these are the sorry. This is predictive parsing algorithm. It will communicate with input buffer, stack, and parsing table, and it generates a parse tree. Whether the input string is successfully parsed by using this parsing algorithm, then the parse tree will be constructed. Now, predictive parsing uses a stack and a parse table to parse the input and generate a parse tree. Both stack and the input contains an end symbol dollar to denote that the stack is empty and the input is consumed. That means this stack contains a dollar at the bottom of the stack, and also at the input, each input is going to followed by a dollar symbol. At the end of input buffer, dollar will be represented. The parser referred to the parsing table to take any decision on the input and stack element combination. That means this parsing algorithm is going to communicate with input buffer and stack based on the current reading input symbol and top of stack element. This parsing algorithm will take necessary actions to generate the parsing. So this is the structure of the parsing algorithm. Next, LL of K. Let us discuss few points about this LL of K. That means LL means, first L means left to right. The input will be read from left to right. Each character by character, the input will be read from left to right. And the second L means leftmost derivation. That means in derivation can be in derivation process, it can be done in leftmost manner. That means leftmost non-terminal will be replaced by its equivalent production in the sentential forms. What is that K means? K is a token of look ahead. That means K is a look ahead symbol. how many number of look ahead symbols are going to read when the parsing is going to be done. If it is one, then at a time only one symbol is going to be, that means only one symbol is going to be read from the input buffer. Now LL of K parser will predict the production and it replaces a non-terminal. Why it reads a non-terminal? As soon as a parser reads a non-terminal, then this parsing algorithm decide whether that non-terminal is going to be replaced by which production. If it is having a number of production, which production is going to be replaced by that non-terminal to derive a terminals, to derive input string. That can be done by using this parsing algorithm. So initially, top of stack contains non-terminal if dollar, and then after top of stack contains starting symbol of the grammar, and this symbol is going to be replaced by the production rule by considering table, parsing table entry, and also top of stack element and input string based on the top of stack element which that is non-terminal, and input string that is terminal. Based on these two elements, parsing algorithm decides which operation to be done and which production is to be chosen to derive particular input string. Now the main point here in this parsing algorithm is parsing table. See, parsing algorithm communicate with input buffer, stack, and parsing table. See, depending on the current input symbol which is read from the input buffer and top of stack element, it will check the entry in the parse table. It will check the entry in the parse table. Then the parse table, based on the entry, that production will be replaced in the stack. That top of stack non-terminal will be replaced by that production. See, let me discuss about the steps to construct the parsing table. To construct a parsing table, first of all, we should construct first and follow set of the all non-terminals in the given grammar. Then, after constructing first and follow of the every given non-terminal in the grammar, we have to construct a parse table. Now, this parse table consists of rows and columns. All the rows are going to be represented by non-terminal in the grammar. For example, if the grammar is having 5 non-terminals, then the parse table contains 5 rows in it. Then, parse table columns will going to be represented the terminals. Whatever the terminals which are going to be derived by using that grammar, all the set of terminals, all those terminals will be representing columns and followed by dollar also. Productions are added into the table entries. See, after constructing first and follow, all the productions, if the grammar is having n number of productions, all those n number of productions should enter into the table. That means we should make the entry into the table for all the productions. How each production is going to be placed in each one cell of that one cell of that parsing table, how, where, in which cell it is going to be stored, it depending on the condition. See, if the production is x deriving y, that means if a production is in the form x deriving y, and that y is not an epsilon, then we should make that entry into m table of row x. That means which the table cell represents a row by that non-terminal and first of y. For example, if this is a production, x is deriving y, then this is LHS and this is RHS. Y is RHS. Now in the table, we have to check the entry, like x is representing this row and y is a non-terminal. The first of y is some so and so terminal, a. First of y is a. Then this production is to be placed in the cell x comma a in the table of row x and column a. So this is a cell where this production is going to be replaced. Okay, when this y is not having any epsilon, y is not deriving epsilon. If y derives epsilon, let us take a production rule x deriving epsilon. This means these type of productions will enter in, will make an entry into the table of which cell it is going to be stored, means in x row and in the column follow of x. Follow of x is going to be the set of some terminals. In that terminal entries, in the terminals, for example, a is a variable that is in the follow set of x, then this production x deriving y will make an entry into the table x comma a. Whenever y is deriving epsilon, right hand side of the production is deriving epsilon, then entire this production will make an entry into the table like this: m of x comma m of x row and follow of x column. So the entry will be made like this. And one more thing to be remember is each cell should have max only one entry. If there is more than one entry, then the grammar is not ll1. If it is having more than one entry, if any cell is having more than one entry, then the grammar is not ll1. By if it is happened, then it is not possible to construct ll1 parsing algorithm, because it get ambiguity to choose which production is to be chosen to produce some sort of input sinks. That means there is an ambiguity in the in choosing of the production rules. Now let me explain parsing, ll1 parsing with help of one example. Let us take this grammar: e deriving t e dash, e dash is deriving plus t e dash epsilon, t deriving f t dash, and t dash deriving star f t dash epsilon, f deriving EID. So this is a grammar having some production rules. First of all, we have to construct the first step in construction of LL1 parsing is compute first and follow. Compute first and follow. How we are going to compute first and follow? That we discussed earlier, because first means, what is mean by first? First is a all set of initial terminals which are derived by using that non-terminal. Okay, it is the collection of initial terminals of input strings which are derived by that non-terminal is first. What is mean by follow? Follow means it is also initial terminals of all input strings which are followed by that non-terminal. So this is the table which is representing first and follow of the productions of given grammar. Now we have to, based on the first and follow, we have to make the entry into the table for all the productions. Now the steps to construct parsing table. See here, I already discussed, if production is in this form, production is in this form, e deriving t e dash. Let us take first production, e deriving t e dash, and check whether this t is deriving epsilon. Check first of t. Check first of t. Here first of t is open parenthesis and id. That means in wherever, whatever the first of t in those columns, this production is going to be replaced in id and in open parenthesis, because if the production t is deriving epsilon, then entire this production is going to be placed in the cell of e, in the table of m table e row, and column is follow of e. But here this t is not deriving epsilon, t is not deriving epsilon. So this production will be made an entry into the table e row and first of t columns. First of t columns are id and open bracket, open parenthesis. And the next production, e dash deriving plus t e dash. This is going to be enter into the table in this in the row e dash row and plus column, because this production e dash deriving plus t e dash is what is the first of this production, entire production, plus. So this production is going to be have an entry into the table e dash plus this one. And next production e dash deriving epsilon. E dash deriving epsilon means right hand side production is deriving epsilon. So this production is going to make an entry into the table e dash row, and in the column follow of e dash. Follow of e dash is dollar comma closing parenthesis. In dollar and in closing parenthesis. Here in this cell and in this cell there is an entry into the production, there is an entry for the production e dash deriving epsilon. Okay, so this is, in this way all the productions are going to be have an entry into the table, like T derive FT dash. First of FT dash is open bracket and ID. So in those two columns, in row T, in the row which is representing by T, the production is going to be entered. And in the next production, T dash deriving star FT dash. In this production, the first of right hand side is star. So in T dash row and in star column, this production is going to be written in that row and column. Next, T dash deriving epsilon. T dash deriving epsilon is a production. In right hand side of production is producing epsilon. So that production will have an entry in the table of row T dash and column follow of T dash. Follow of T dash is plus dollar and closing parenthesis. So plus in the column plus and dollar and closing parenthesis, the T dash deriving epsilon will have an entry into the table. Observe, observe here. So 1, 2, and 3. That means column is dollar and row is T dash. Here column is closing parenthesis and row is T dash. Here plus and T dash comma plus. So in these cells, it has an entry into that parsing table. The same way on the remaining production will be have an entry into the table. Now this is how we are going to construct a parsing table to parse a input string. Because in this table there is only one production in each cell, there is no cell containing multiple productions, right? So we can say this grammar is a ll1 parser, ll1 grammar, and we can construct ll1 parsing algorithm by using this table. Next we will discuss about the stack implementation, but before that let me explain you the little some other grammar which is not an ll1 grammar. So have a look about this grammar. So have a look. So s deriving I e t s s dash a, s dash deriving es, and epsilon e deriving b. So this is a grammar, and compute first and follow to construct parse table. So this is the table of first and follow of this grammar. First of S is I comma A. I comma A, because S is going to be derived the set of strings which starts with I, and S is going to be derived the set of strings which starts with A. Then S dash, first of S dash is E comma epsilon, and first of B E is B. So this is given and this is computed and it is given in the table. Next, to follow of yes. Follow of yes means as yes is a start symbol, follow of yes contains dollar, and here yes is followed by yes dash. That means follow of yes is also can be computed by computing first of yes dash. First of yes dash is E comma epsilon. So here we are going to include e, as we are not going to include epsilon, because so if we substitute epsilon, then follow of s becomes again follow of s. Next, follow of e, s dash. S dash means here s dash is, check the s dash in the right hand side of the productions. Only in one production s dash is existed, and follow of s dash is nothing. There is nothing to be followed by s dash. That means follow of s dash will be same as the follow of s, that is dollar comma e. And follow of e is here in the first production. E is a non-terminal which is there, existed in the first production, and it is followed by the terminal t. So follow of e become t. Now the construction of first and follow is done, and based on that first and follow, there is a entry in the, there is entry of each production in the parsing table. Here observe S dash row and column E, because S dash deriving ES is a production which is which have an entry into the table E S dash row E column, because S dash row is a non-terminal and it is produces a set of strings which starts with E. So S dash comma E is a row and column values, and in that cell there is an entry for that s dash deriving es. And then s dash deriving epsilon is a production, right hand side is containing epsilon. That means S dash deriving epsilon is have an entry into the table follow of S dash. Here follow of S dash is also dollar comma E. That means in the same cell that S dash row and E column, there is an entry into the two productions. There is an ambiguity. That means whenever we are reading the, whenever the parser algorithm reads a non-terminal S dash and the input string is E, then there is an ambiguity choosing these two productions. Which production is to be chosen to derive the particular input string, to parse the input string. So there is an ambiguity. Then this grammar is not LL1 grammar. So it is not useful to parse the input string by using one look ahead symbol. So to resolve this, LL2 parser will be constructed. And stack implementation of this LL1 grammar, let me discuss. Parser algorithm communicate with input symbol, buffer, and stack. Initially, top of stack, there is a dollar symbol will be placed, and top of dollar, in starting non-terminal will be stored. Starting symbol of the grammar will be stored on the top of dollar, and at end of the input string dollar will be stored. In stack, every non-terminal, the top of stack non-terminal will be read by the parsing algorithm, and at the same time current input symbol will be read. Okay, on reading those non-terminal and current input symbol, it will check the entry in the parsing table. Parsing algorithm will check the entry in the parsing table of that row and column. Row is identified by stack, top of stack element. Column is identified by current input symbol. So based on those two inputs, it will identify the production, which production is to be used to derive the, to parse the given input. And that production will be stored in the stack by popping the element in the reverse order. To eliminate recursion, the production, right hand side production will be stored in the stack in reverse order. Let me explain you about. The parser is a control by a program that behaves as follows. The program considers x, the symbol which is on the top of stack, and a, that is a current input, that means which is read from input buffer. Those two symbols determines the three possibilities of taking actions. See here, top of stack element is x and a is a input buffer. If top of stack element is x and it is an input buffer, if these two are equals to dollar, that means on top of stack there is a dollar, and at the input currently reading input symbol is dollar, then we can say that parsing is done successfully. If top of stack element, that is first case. If top of stack element is x and current reading input symbol is a and which is not equals to dollar, then x is popped, and the whatever the productions which are in the whatever the set of terminals or non terminals which are in the right hand side of the production, that will be stored in the stack, that will be stored in the stack in reverse order. That means if input the top of stack element is x and input string is a, then it will check the parse table first. Initially it will check the parse table of in row x and in column a. Then the production will be right hand side of that production will be stored in stack in reverse order. Let us take x is deriving a B is a production which is there in that particular cell. Then this A B is going to be replaced to X in the top of stack like B and A. Then this will be further derived. So because in leftmost derivation initially this A should be explored. That means this A should be replaced by its production rule. So the in the stack the productions will be stored in the reverse order. And whenever x is a non-terminal, the program consoles entry in the table x of m of x comma a of parsing table m. If the entry is a production, if the entry is a production like x deriving u v w, then the parser replaces x which is on top of stack by w v u. As I discussed it just now, the right hand side production will be stored in the stack in reverse order. Whenever if the input symbol, if the top of stack element is non-terminal and the input symbol is terminal, and if these two are equal, that means top of stack element is also terminal and input symbol is also terminal, then uh, parsing algorithm advances the input pointer to the next symbol in the input buffer. That means there is a match found, so the next input symbol will be read to parse that next input symbol. Next, LL1 stack. Let me explain the parsing process by using one example. By using this example, let us parse the input string ID plus ID star ID. Okay, now table parsing table is constructed. After that, top of stack element is initially dollar, and then starting symbol of the grammar, that is e, will be stored in the stack. Now currently reading input symbol is id. Now check, e and id is verified, and check the entry in the parsing table of row e and column id. Okay, then check that cell. If there is a production in that cell, then that production right hand side of that production will be stored in the stack in reverse order. See, here initially stack is empty, parsing table, and dollar is on top of stack, e is a starting symbol of the grammar. Now compare this E and ID by parsing algorithm. Okay, parsing algorithm will compare E and ID. E is a non-terminal and ID is a terminal. These two are not equal. So what it will do? It doesn't advance us. It doesn't move to the next input string, next input character. Meanwhile, E will be replaced by its production right hand side of the production. Whenever this e is having multiple productions, how it could know, it could be the production will be identified from the parsing table in the row of e and column of which is representing by id. That cell will be identified like e deriving te dash is a production which is in row e and column id. So that will be E is in stack, E is replaced by TE dash in reverse order. E is replacing T E dash. See, E is popped out and E dash will be inserted into the stack. Then T will be inserted. That means in the reverse order, the right hand side value of the production will be stored. And the next is T. Top of stack element is non-terminal T. And the currently reading input symbol is ID. See, compare these two and check the entry in the parse table in T row and in ID column. And that is T deriving FT dash. Now, FT dash is going to be pushed into the stack in reverse order. T will be popped, then T dash will be pushed, and then F will be pushed. Now F and ID will be compared. See, in F row in ID column, there is a production rule F deriving ID. F is popped and ID will be pushed onto the stack. Now compare ID and ID. See, top of stack element and currently reading input symbol is matched. That means the parsing algorithm advances the input pointer to the next location, and one element from the stack will be top of stack element from the stack will be popped. Now the currently top of stack element is T dash and the input string is plus. So compare these two and check the entry of the parse table of T dash row and plus column. That is T dash deriving epsilon. Whenever right hand side production is deriving epsilon, pop the top of stack element. Next one is E dash. Top of stack element is E dash and current input symbol is plus. So come check the parse table for the row E dash and column plus. There is a production E dash deriving plus T E dash. Now this right hand side production will be stored in the stack by removing top of stack element, and that is E dash T and plus. Now compare top of stack elements and current input symbol plus and plus. So these two are equal. So what will happen? Input pointer will be going to point the next input symbol from in the input buffer, and top of stack element is T. Now T and ID will be compared. So T is T in the T row in ID column, we have a production T deriving FT dash. Okay, now this T deriving FT dash is a production. This T will be popped and T dash F will be pushed onto the stack. Now F is compared with ID. In the F row in ID column, there is a production F deriving ID. Then F is popped and ID is pushed onto the stack. Now ID and ID will be compared. So ID and ID are equal as top of stack element and currently reading input symbol is equal. Then pop one element from the stack. And the next one is T dash. T dash and ID, T dash and star will be compared. The same way till it reach the dollar or bottom of the stack and last symbol in the input buffer, that is dollar. Whenever these two are equal, then we can say that parsing is done successfully. So this is a stack implementation of the given grammar by using LL1 parsing algorithm. Now say initially E and ID will be compared. In the parse table in E row and in E column, there is a production E deriving TE dash, and that will be stored into the stack in the reverse order. E dash, first initially E dash will be pushed, then T will be pushed. So top of stack element is now T, and T and ID will be compared. So in T row, in ID column, there is a production FT dash. So pop this from stack and T dash F will be pushed onto the stack. Now F and ID will be compared. current input symbol is id, and the top of stack element is f. By comparing these two, check the entry in the parse table in f row and in id column. So there is a production, f deriving id is in that cell. So here id is pushed, right hand side of the production will be pushed onto the stack, then id and id is compared. Input top of stack element is id, the top of stack element is id, and input buffer currently reading input symbol is id, so these two are equal. Then pop the element from the stack and advance the input pointer to the next character. Now t dash and plus will be compared. Okay, in t dash row in plus column there is a production t dash deriving epsilon, so t dash will be popped. Next e dash and plus will be compared. In e dash row in plus column there is a production e dash deriving plus t e dash, so e dash will be pushed onto the stack. Next T, next plus. Now here plus and plus will be compared. These two are matched. Match plus. Here match ID, match plus. Okay. Stop of stack element will be popped, and this plus will be this pointer will be advanced to the next character, advances to the next character. Next, now t is a top of stack element and id is a currently reading input string. Now compare these two, check the entry of t row and id column in parse table. Then there is a production t deriving ft dash, push this onto the stack. First initially t dash and then after f. Now check f and id. So we got in the f row and in column cell we have a production f deriving id dash. Now we are id, and id will be pushed onto the stack. These two will get matched. If the string is matched, then pop the element from the stack and advance the input pointer to the next character. Okay, t dash star will be compared, and in t dash star cell in t dash row star column there is a production t dash deriving ft dash. Now push t dash ft dash t dash f and star onto the stack. Now star and star will be compared. Pop top of stack element, there is a match found. Pop the top of stack element, advance the input pointer to next id. Now f and id will be compared. In f row in id column there is a production f deriving id. Now pop this f and push id onto the stack. Now id and id will be compared. These two get matched. That means pop this id from the stack and advance the input pointer to the next symbol. Now t dash deriving dollar. So in t dash deriving dollar there is a production in t dash deriving epsilon, so this will be popped. And next top of stack element is e dash deriving, oh sorry, e dash and dollar. E dash row dollar column we have a production e dash deriving epsilon. That means e dash will be popped, and the next top of stack element is dollar, and the currently reading input symbol is dollar. That means whenever these two are equal and it is equals to dollar, then we can say that the string is parsed successfully. So top down parsing expands a parse tree from starting symbol to leaf symbols, and always expanding leftmost non-terminal will be expanded. That means leftmost non-terminal will be replaced by its productions to produce a given input string. And the parse tree for that example is by using the uh, parsing steps, parsing by using the stack implementation, the parsing steps, we are going to construct the parse tree, and the parse tree will be like this. So initially id plus id star id is a input string which is passed by using LL1 parsing algorithm. Thank you.